Welcome to EDU World Space.
All right. In question 17, we are looking at the intermolecular forces that each one of these substances has to overcome in order to go from a liquid to a gas. So we're going from a liquid to a gas. The substance has to break all the intermolecular forces. And so we're trying to figure out what sorts of intermolecular forces each one of these substances has. So the first one is SO2. And if you draw out the Lewis structure for SO2, which sometimes we need to do in order to figure out our forces, because we need to see if a molecule is polar or nonpolar. So there are 3 times 6 valence electrons. So this molecule has 18 valence electrons. So it's going to look like 2 oxygens bonded. And in order to only use 18, you're going to need a double bond here. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18. So that unshared pair on sulfur is going to cause this to have a bent shape. And due to that bent shape, this molecule is going to be polar. Therefore, the types of intermolecular forces that this can have is, because it's polar, it will have dipole-dipole forces. And then basically all molecules will have London dispersion forces. Part B gives us the molecule CH3, COOH. So in this molecule, we don't really need to draw it out to know that it's going to be polar. I have one end of my molecule that has oxygens and hydrogens, so this is definitely a polar molecule. But even more specifically, it has a hydrogen that is bonded to an oxygen here, and therefore it can have hydrogen bonding. And we can also say it has dipole-dipole, although hydrogen bonding is really sort of a special type of dipole-dipole. And then again, all molecules are going to have your LDFs. In part C, we're given the molecule H2S. This has a total of 8 valence electrons. It's going to basically look like water, but with a sulfur in the middle instead of an oxygen. So we have our sulfurs in the middle. It's going to have 2 unshared pairs on it to get all 8 valence electrons. Because of the 2 unshared pairs on there, this is again going to be a bent shape. And because it is bent and these are polar bonds, this will be a polar molecule. So this will have dipole-dipole. And again, it will have LDF. And it's important to say that it will not have hydrogen bonding, because in order for hydrogen bonding to occur, you have to have a hydrogen that's bonded to an F, O, or N, not a sulfur. So this will not have hydrogen bonding, but it will have dipole-dipole and LDFs.